Hello, welcome back to a new video here. Um, I'm gonna talk about the product rule. Here, I'm gonna write the formula for it. Or, yes, the formula for it. D over dx. We're looking for the operator. This is the operator. Remember, we have a parentheses, and you have the d over dx. That means you're gonna derive it, what's inside the parentheses. So for this scenario, it's gonna be f of x times g of x, which is not the same thing as finding the derivative of x, f of x, and g of x prime. They're not the same thing, they're wrong. So to save yourself some time, please do not do that. And this is how you actually do it. I like doing it this way. So let's say we have x squared times cosine x, or cos, and I like getting the first function. So we'll separate this into two functions. This is f and g. Okay. So I like doing like this, the cross. I'm gonna have x squared. Well, first, let me give you the formula. Because this is, you want to understand what the formula. And the formula derives from the limit definition of derivatives. Yes, the limit definition of derivatives. You can write it like this: g of x plus g of x times f prime x. I like writing it like this. They're both the same thing. G of x times f prime of x. You understand why I like writing it like this? This is especially because of the quotient rule. The quotient rule is basically the same concept, but it's subtracting and the denominator is squared. It's it's to the power of two. So whatever polynomial or whatever operator you have on the bottom, it's gonna get to the power of two. It's only so far. I'm pretty sure this is only for when you have two derivatives. uh, Sorry. Let me continue. And g prime of x times. Actually, let me rewrite this. It doesn't really matter for the order. It just matters the way. Actually, I'll write it like that. G x prime times the first function. And since I gave the example of x squared, let's give it the value of h of x. We're trying to look for h of x prime times cos x. So we're gonna set it up. I'll show you my way. You can do it another way. Cos goes here. Cos is the one that's not gonna get derived, but the first function is gonna get derived. So the derivative of x squared is x, oh, it's 2x, 2 times x, plus we're gonna do the same thing, we're just gonna move everything. So x squared doesn't get derived, but cos does. And the derivative of cos is negative sign. In the video, I'll probably do the traditional way of doing derivatives for the sinusoidal waves, or cosine and sine. And for another video, I'm going to show how to do the derivative for tangent. The tangent one will be applicable after this video because it uses the quotient rule. Sine and cosine, you can do them with the limit definition. And yeah, okay, so this, and I'm gonna simplify even further. Um, cos x, actually, it doesn't really matter where the x 2x goes. It can be in front or after the cosine, but I like having the cos the any polynomial in front of it and anything adding afterwards. It makes it easier to read. And actually, this is wrong. Negative x squared times sine, and this will give you the derivative. I'll go over another example here. Two. I'll do two examples. Okay, two more. Two more. Just one more after this one. X squared plus 1. This is a 2, my bad. 2x minus 3. So let's derive of our setup. X plus 1 and 2x minus 3. We multiply them. I like to put parentheses and brackets to identify its one function from another. Okay, and we add and we do the parentheses and we just move these in order. Or we can do the way we did. For this scenario, I'll show do that way. Or my way. Okay, I'll just do this way. It doesn't really matter. Just remember when it's multiplication, it doesn't matter what order, because 2 times 3 is equal to 6, and 3 times 2 is equal to 6. Do the same thing. Let's, I don't know why I wrote f of x. I think I do. Never mind. But x squared minus 1 times 2x minus 3. Okay, and I think I forgot to square for this one. My bad. Remember, math happens. I'll put the prime notation here on top of it. And here I'll note it as the derivative first. Y prime equals 2 of x minus 3 times the derivative. The derivative of x is it's 1. We have an imaginary 1. Oh, we have a 1 in front of it. It's not showing because 1, it doesn't really matter if you have a 1 in front of it. But yes, it's times 1 plus the derivative of the second function. Yes, so x squared minus 1 parentheses. So it would be 2. Okay, and if I were to simplify this even further, I would have done this plus x 2 squared minus 2, and rearrange this again. Squared plus 2x minus 5 as your setup, as your derivative, my bad, for the product of these two functions. And here, I'm going to give another example. 2 square root of 3 square root of s. The function is f of s. And we're trying to look for the derivative of f of s. The first function is going to be 2 times square root of s plus, let me end it, plus 1. The second function is going to be 3s. Okay, so let's put them in order. 3s times 2 square root of s plus 1 plus 2. I'm gonna put the G. I actually don't remember how I was putting my things, but, oh, actually, I gave it away. Arrows intercept, they intercept, and they parallel afterwards. Okay, sorry. 2 square root of s plus 1, then we multiply by the derivative of this function. It's really bad notation, but my bad. 3s times the square root of s is basically the same thing as this. You do the product rule. First, we move the 1/2. It's going to be 1 over 2, and it's going to be equal to negative 1/2. So the function would look like this. After everything is done, the function will look like square root of 2. 2, my bad. Not 2. 2 times the square root of s. Because it's a negative, negative, it becomes a reciprocal of it. Okay. And any constant, remember, the derivative of any constant is 0. So these two are multiplying. So we can rearrange. Actually, I'll do it afterwards. I'll try and finish as fast as I can. 2s, looks like a 5, my bad, plus 1. And the derivative of this is 3. I'm going to distribute. Oh, after I do this, I'm actually going to rearrange my function plus 6 times the square root of s times plus 3. I just distributed 3. You don't have to simplify, but it just looks nicer. It's way more organized to have it simplified. And we're done for product rule. The next video is going to be on quotient rule.